question 1 is on complex numbers. So there's part A, B, C, D, and that's it. Okay, so there's 4 parts. So this part D seems to be, you just divide 2 complex numbers. Part C, okay, so you're just verifying that the modulus of part of Z1 is greater than the modulus of Z2. So that seems fine. From the diagram, is it possible to say the modulus of Z1 is greater than the modulus of Z2? That should be. Oh, and part 1 is you just plot it. So let's just get on with it. Z1 is 3 minus 4i, and Z2 is 1 plus 2i. Plot Z1 and Z2 on the Argand diagram. On the Argand diagram over. Must have been a typo. So I want 3 along the real axis and minus 4. So that would be Z1. And Z2 is 1 along the real axis and plus 2i. So that would be Z2. So that's all we needed to do for the first part. So from the diagram, is it possible to say the modulus of Z1 is greater than the modulus of Z2? Well, the modulus is the distance from the origin. Now, I would say that Z2 or Z1 is further away along the real axis, since it's 3 instead of 1, and it's further along the way along the imaginary axis, since it's 4 instead of 2. So it's clearly further away. Now, how do you justify that? Well, it says, from the diagram, is it possible to say the modulus of Z1 is greater than the modulus of Z2? Well, yes, because the modulus is the distance from the origin, and Z1 is further away than Z2. Now, I could work that out precisely, or I could say, well, since both it's further along the real axis and the imaginary axis, the distance is greater. So the main point would be that it's Z1 is further, the distance from the origin is greater, and whatever way you want to go into that in greater detail, if you want, you can, but it's not necessary. If you just say that Z1 is further than Z2, or the distance from the origin is greater than for Z2, then you're right. So part C says verify algebraically that's the case. So then that just means explicitly work it out. Well, Z1 was 3 minus 4i, so then the modulus of Z1 is 3 squared plus 16, since you just square the coefficient for the real and the imaginary to get the modulus. Well, the square root of that. So that's 16 plus 9, so that's 25. The square root of 25 is 5. Z2, well, that's equal to 1 plus 2i. So then 1 plus 4. So you take the square root of the sum of the coefficients squared. So that's going to be the square root of 5. So that's going to be 2 point something, which you can work out in your calculator. And that's about 2.23. So 5 is greater than 2.23. So the modulus of Z1 is greater than the modulus of Z2. Finally, we just need to work out Z1 divided by Z2. So you have to remember how to divide complex numbers. So I want to work out Z1 divided by Z2. Well, that's 3 minus 4i over 1 plus 2i. So then, how do you divide complex numbers? Well, you have to remember that if I multiply a complex number by its complex conjugate, I end up with a real number. So what I do is I multiply the number on the bottom by its complex conjugate, so then I'll end up with a real number at the bottom and a complex number on top. So the complex conjugate of 1 plus 2i is 1 minus 2i, so I end up with 3 minus 4i multiplied by 1 minus 2i divided by 1 plus 2i multiplied by 1 minus 2i. So then, well, I'll leave the top at the moment and just work out the bottom. Though if you want, you can do the multiplication on the top at the same time. So what's 1 plus 2i multiplied by 1 minus 2i? Well, that's just going to be 1 plus 4, because you multiply it by 1 first, so you'd end up with 1 minus 2i. Then you multiply it by plus 2i, so the plus 2i will cancel with the minus 2i you got to begin with. So you end up with 2i multiplied by minus 2i. That gives you 4i squared, which is minus 4i, or which gives you minus 4 multiplied by minus 1, so that's plus 4, and you end up with 1 plus 4. So now I just need to multiply the top. So 3 multiplied by 1 minus 2i gives me 3 minus 6i, and then I multiply the right hand side by minus 4i. So minus 4i times 1 gives me minus 4i. Minus 4i times minus 2i gives me plus 8i squared. So I squared is, of course, minus 1. So now we just work that out. So that's minus 8. Because I squared is minus 1. So I have 3 minus 8 gives me minus 5, and I end up with minus 10i, because minus 6i added to minus 4i gives me minus 10i. Divide that by 5 and end up with minus 1 minus 2i. And just to expand that bit, because that wasn't particularly clear when I talked about it earlier, 1 plus 2i multiplied by 1 minus 2i, well, that gives me 1 minus 2i, because when I multiply the 1 minus 2i by 1, and then I multiply 1 minus 2i by plus 2i. So I'm multiplying this bracket by 2i, so the 1 becomes a plus 2i, and then I add 2i multiplied by minus 2i, so that gives me 4i squared. So then that means, well, the minus 2i and plus 2i cancel, so I end up with 1 minus 4i squared. Well, I squared is equal to minus 1, so I can get rid of the I squared and flip that sign, and I get 1 plus 4, which is what I wrote there. And we're done. So we just worked out part D, we did algebraically that the modulus of Z1 was greater than the modulus of Z2. We plotted the numbers on the Argand diagram, and that's question 1.